Good day everyone! Today we are going to study constructing polygons or MELC 41. I am your teacher, Ma'am Juliet H. Ricasata, and together, let's discover the wonderful world of mathematics. Our terminal objective is to construct triangles, squares, rectangles, regular pentagons, and regular hexagons. Our enabling objectives are as follows. 1. Determine the materials and steps needed in constructing polygons. 2. Construct polygons properly. And appreciate the importance of polygons in real life. To construct polygons, we need the following materials. 1. Straight edge or ruler. 2. Pen or pencil. 3. Compass. 4. Clean sheets of paper. Here are the steps in constructing a triangle. There are 1, 2, 3, 4, up to 10 steps here, and there are expected outcomes on this second column. I will show you shortly on how to perform these steps, so I want you to watch closely, follow, and learn. I will show you how to construct a triangle with these two cases. The first case is with the actual sides given, and the other one is with the side lengths given. Let's start. Let's mark a point first here. That will be one of the vertex of our triangle. Then, with our compass, let's use the segment BC by extending our compass, adjusting it to fit its size. And then, using our vertex here, let's make an arc here. Okay, we know that the next point, so we are making here segment base BC. So we know that the point C, let's name this as point B, by the way, and this one as point C. Okay, now we have to find the third vertex for our triangle. So let's use the second segment, AB. Let's adjust our compass to fit its size. Okay, so there is it. To make the segment AB, so we have to use B as the center of our compass, and we have to make an arc over here. Okay, we don't know yet where is the exact location of point A, so let's measure segment AC this time, the third side. Let's adjust our compass to its size, and then with point C this time as the center, let's create an arc crossing the first one that we have created. And now we are sure that this point of intersection is point A. So we're now going to connect these points using our straight edge or ruler. This is segment BC. We have this points A and C, C and A. So this is side AC, and this one is the side AB or BA. And now we have created our triangle. We can name this as triangle ABC. There you have it. Let's now create this triangle with the following given. Segment OY, that is 5 centimeters in length. Segment JY, which is 7 centimeters. And segment JO, which is 6 centimeters. So we need to determine first our point here as the first vertex. And then with the use of our ruler, we have to measure first, or it's easier to first construct the longest side. Let's use the JY, which is 7 centimeters. Okay, let's adjust our compass to 7 centimeters. And there you have it. And then, with this point as our reference or the center, let's create an arc here. Okay, again, we are making the segment JY. So, we know that this point is point J, and this point somewhere here, anywhere on this arc is point Y. So let's name this point as Y. And now let's find the third vertex by using the segment OY first, which is 5 centimeters. So let's adjust our compass to 5 centimeters. Okay, there it is. To create OY, we use the vertex Y as the center and create an arc over here. And now, to find the exact location of point O, we need this third side, which is JO, that measures 6 centimeters. So adjusting our compass to 6 centimeters. Let's have this. Okay. And then point J will be our center. So we create an arc crossing the first one. And now the point of intersection is the point O.
points. Next is to connect these points. So we know that this is segment JY that measures 7 centimeters. This side is side OY that measures 5 centimeters. And the third side is side JO that measures 6 centimeters. And there you have it. Our triangle can be named as triangle JOY. Simple, right? Do you follow?
To construct a square, we have to perform these 10 steps. So, let's try it.
We will use two cases here in constructing a square. The first one is when the actual side is given, and the other one is when the measurement is given. So, let's do it. First, we have to extend the line segment AB here, the right side. Let's extend it. And then, next is we have to create a perpendicular bisector of this segment passing through B. To do it, let's create an arc with B as the center, an arc crossing here, and another one on the left side. And now let's adjust our compass. Let's make it a little bigger with the center here on the first point that we have created when the arc intersected it. Let's make it a little bigger. Let's draw an arc above, and this time with this point as our center, let's create another arc above crossing the first arc. Okay, now this point of intersection will be the point where our line segment or perpendicular bisector will pass through it. With the point B, we connected this point and the point B, and now we have drawn a 90-degree angle here. Okay, next is we are going to determine the measure of the segment AB with our compass. Let's set our compass to the size of segment AB. Okay, there it is. And then let's create an arc above the point A. Also, the same length, this time would be as our center. Let's create an arc above this segment, the perpendicular bisector. And now we know, without changing the length or width of our compass, using that point as our center now, let's create an arc crossing this arc. So we have created now two more points, this point and this point. Let's name this point as C and this as point D. And now the next step is to connect these points to finish our square. So this is CD and this is the segment AD. So we know that these angles are also 90 degrees. Therefore, we have created here a polygon which is a square, and we can name it as a square ABCD. There you have it. Let's now create a square with a length of 6 centimeters. So first, let's draw a line segment that measures 6 centimeters. Let's determine it using our ruler. So this point and this another point is the second vertex. Okay, so now this is 6 centimeters. Let's do the steps that we did in the first case. So we have to extend this line, extend this further, and then we have to create an arc crossing this segment, an arc with this point as the vertex. Let's create a small arc here, another arc on the other side with the same length of our compass. So now with this point of intersection as our center, let's create an arc above. Let's make the length of our radius bigger. Let's draw an arc above the line segment, an arc above, and another one with this point of intersection as the vertex. Create an arc crossing it, and the point of intersection is this. Let's connect it with the vertex here, the point that we have determined earlier. So connecting this slightly, we know that we have created a perpendicular bisector, therefore this is a right angle. And now, using our compass, setting it to 6 centimeters, let's set it into 6 centimeters. Okay, there you have it. So also, if you can see it, it's this 6 centimeters. So with this as the vertex, let's create an arc above it, knowing that there is the second or the third vertex, and here is the center of our compass. Create an arc above it, and then with that point as our reference and the center of our compass, create another arc crossing it, and there you have the fourth point. Now the next step is you just have to connect all of these points to create our square. Let's now create this segment connecting these 2 points, and this one and that point. Okay, we can check the length of it is 6 centimeters, 6 centimeters, 6 centimeters, and of course this measures 6 centimeters. So there you have it, our square that has a side length of 6 centimeters. And let's name this as square MATH, since we are not given the exact or definite name for this point. So let's just name it as square MATH. There you have it. I hope.
Here are the steps in constructing a rectangle. So as you can see, there are just 8 simple steps here. So what are you waiting for? Follow me.
To create a rectangle, we need to draw first a square. So let's do it. So this time I'm going to create a square that is 5 centimeters in length. Okay, so let's determine this point of the vertices. Okay, and then I'm going to extend it now. Okay, so now let's create a perpendicular bisector for this. Let's make an arc with this vertex as the center and another arc crossing the segment. Okay, and now with the point of intersection, we have to make the arc bigger, the length of the radius bigger. So let's have an arc above and another one with the vertex, with our compass pointing on this vertex, and then we've created an arc. So above here, let's connect the point, this point, and that point of intersection. So we have drawn here a perpendicular bisector, and then we have to determine the 2 more vertices of our square by using our compass and setting it to 5 centimeters. This one is 5 centimeters, 5 centimeters in length, 5 centimeters. Okay, so let's create an arc here, another one here, without changing the compass, the width of our compass. And now we have determined the points here, this and this. Now let's connect them with our ruler or straight edge. Connect this one. Oops. Well, there you have it, our square. So we have created here a square ABCD. Next step is to determine the midpoint of the segment AB. To do that, we need our compass. So we have to create an arc somewhere above here with B as the center. I have discussed this on MELC 37. So if you want to go back on that video to learn on how to create the midpoint or the bisector. So let's now create another arc here with A as the center. So we have to do it also below the segment AB. So we have to use B again as the center here. And now we have these 2 intersecting arcs. We now connect these 2 points with our ruler. So now we know that this point of intersection is the midpoint of the segment AB, and let's name this point as point P. Next step is we have to measure the length of PC from point P to point C with our compass. So let's adjust our compass to reach point C, and then we have to create an arc crossing the point P up to this line below, the line that we have extended, the line segment that we have extended a while ago, the AB one. We have created the square, and now we have to create a segment that is parallel to segment BC. To do it, by the way, we have a point of intersection here. Let's name this point as point Q, and then let's again create a parallel line somewhere here that is parallel with segment BC. So first, to do it, you have to measure the length of BC with our compass. Now with this same measure of BC, let's use this length with Q as our center. Let's create an arc somewhere here, and then let's now adjust our compass that will fit the measure of segment BQ. Okay, BQ is this big, and then let's draw an arc with C as the center. Draw an arc here to form an intersecting arc with the first arc, and this point of intersection will be the next point. Side will pass through this point. Let's draw and connect these 2 points. Let's draw a segment connecting these 2 points. So this segment is parallel with this segment BC, and now let's connect these points point C, and this point, by the way, let's name this as point R. Okay, let's connect point C and point R here. Okay, there you have it. So we have created here a rectangle AQRD. Let's just erase the extra erroneous constructions that we have here. Our rectangle AQRD. You follow? Very good. So there you have it, our rectangle AQRD. I hope you follow.
We are now going to construct a regular pentagon inscribed in a circle. So when we say inscribed, it means that the pentagon is enclosed in a circle and the vertices touches the circle. So as you can see, we have 11 steps here. And look at the last step. We have here a drawing of a pentagon. Our outcome should be like this, wherein the vertices of this pentagon touches our circle. So, what are you waiting for? Let's go!
Create first a circle. So any size will do. Okay, let's try to draw it. Make sure that the center is fixed. Oops. So there you have it, our circle. Let's determine the center and let's name this as point O. Now with the use of our ruler, let's determine the diameter of this. Let's use our ruler. Diameter is the segment that passes through the center. Let's name this segment, our diameter, as CM. Next step is we have to create a perpendicular segment to CM at point O. So we need to use our compass to do it. We have to use point C as the center and make the compass wider somewhere here. Let's draw an arc somewhere here. And point M this time as the center of our compass. Draw another arc intersecting the first one. And the point of intersection here is this. And let's connect these 2 points, the center and that point, with our straight edge or ruler. Okay, so this point on the circle, let's name this as point S. Next, we have to find the midpoint of our segment SO. So to do that, we need our compass again. So we have to create an arc. We have to get the midpoint of SO. So we have to make an arc somewhere above here and below the segment SO. So here, and then with point O as the center, create an arc crossing the first arc above and below. So we have 2 intersecting arcs there. So we have to connect those points of intersection with our straight edge or ruler. Connect them. So we know that this point is the midpoint of SO, and let's name this as point L. Next, let's use our compass. Set the compass on L as the center and adjust it to S. And let's draw a circle passing through the point S and O. Okay, next draw a line from M through P. So we have to draw a line through P that will also intersect the small circle at these 2 points. Okay, let's name this point as point N and this one as point P. Set the compass on M and adjust its width to P. Okay. Then let's draw an arc crossing the given circle through this. Okay. Name this point as point A and point E. The compass to M and adjust its width to N. Then draw a broad arc that crosses the given circle at two different places. Let's name this point of intersections as B and D. Draw a line from AB, BC, CD, DE, and AE to form the sides of our pentagon. There you have it. I hope you followed.
Here are the steps in constructing a regular hexagon inscribed in a circle. So there are just 6 steps here, and I will show you now on how to perform these steps one by one.
Draw first a circle. Drawn a circle here with point O as the center. Now let's mark a point anywhere on the circle. Let's say it's this point. And then let's set the compass in this point. We know that this is the length of our radius. So let's point our compass here. Let's set it here and then make an arc here. Okay, somewhere on the circle. And then let's do it again with the center at this point. Then create an arc here, then do the same thing on the next point of intersection of the arc that we have created. And we have to draw another one, and then the last one here. So you can see we have created here 1, 2, 3, 4, 5, 6 points already, and these points would be the vertices of our hexagon. Okay, we use our straight edge or ruler to connect these points. Name this hexagon as hexagon wealth. Health is wealth. We're done. I hope you were able to create your own polygons too by following the simple steps that I have shown you. With that, congratulations and thank you.
Let's now take a look at some applications of polygons in real life. One of the applications of polygons is through tessellation, which is the arrangement of shapes closely fitted together, especially of polygons in a repeated pattern without gaps or overlapping. Here are some examples of tessellation. Tessellation is applied in making cathedral windows just like this and this. You can also see tessellation in the design of pavements and floor tiles. Polygons may also be seen in the furnitures inside your own houses, from floor to ceiling. The application of polygons is very evident in building structures just like the pyramid, the Great Wall of China, the houses and the different buildings in the city, the malls, the stadium, and other structures in the modern world. Nature itself speaks loudly about the application of polygons in real life. Polygons are everywhere, and so math is also everywhere. Don't you think it's enough reason for you to love math? I hope you learned a lot. With that, God bless, stay safe, and maraming salamat!